Hi students, and we're going to be taking a look here at another example of solving a right angle triangle using our trigonometric ratios. So to start us off, what we want to do is to simply find out what our labels are going to be. So we're going to label all our sides, so our hypotenuse, our opposite side, and our adjacent side. So we're going to make a catalog of the information that we have. So A, well, this is our hypotenuse. B, this is our opposite. And the value length of 7.9, this is our adjacent side. So the idea is that your known side, in this case here, this guy, tells us which trigonometric ratios we're going to use. So anything that uses an adjacent length. So we're going to use cos and tan for these two here. So let's see what we get. We're going to find out what the cosine of 64 is and what the tangent of 64 is. So the cos of 64 degrees, this is equal to adjacent over hypotenuse. So in this case, what we have is our adjacent side is 7.9 and our hypotenuse is A. Now for tan of 64 degrees, this is opposite over adjacent. So what we have is B over 7.9. And what we're going to use here are our skills for solving rational expressions that we just did in our last video. So we're going to take a look first at the cosine of 64 degrees is equal to 7.9 over A. Remember, well, what is our goal? Our goal here is to solve for A. We want to get A by itself. So we can use the fact that if we have something in the denominator and we want to find out what it is, we're allowed to swap it with everything on the opposite side of the equality. So what we're going to have here is if I swap A with everything on the left-hand side, that's a legal move. So let's see what that gives us. This is going to be A is equal to 7.9 divided by the cos of 64 degrees. So keep in mind that as long as you're making legal moves, then you're going to get correct answers. So the idea is that algebra, the more micro steps that you memorize, the faster you can solve problems. And in this case here, if we approximate the value to one decimal place, we get 18.0. Now there are no units given to us in this question, so we're going to leave this unitless as well. So now let's do our tangent question here. So we had the tan of 64 degrees is equal to B over 7.9. So we want to make sure that we're using the right skill in the right place. So in this case, our unknown quantity B is in the numerator. So we're going to use our SAM-DEB approach here. In this case, we're going to say, well, what's being done to B? Well, it's being divided by 7.9. So we're going to multiply both sides of our equation by 7.9. And let's see what that gives us. We're going to have 7.9 times the tan of 64 degrees is equal to B. So now let's find out the approximate value. Punching this into our calculator and bringing it to one decimal place of accuracy, we get approximately 16.2. And what we're going to be taking a look at next is checking to see if our answer is correct.